Hello, in today's video we're going to be discussing section 5.1, which is on solving systems of equations by graphing. Today's going to be an introduction to solving by graphing, and then there will be 2 videos following completing our section on 5.1. Our essential question in this video and in this series is, how do you solve a system of equations by graphing? What does a solution represent? So first I'm going to start by just refreshing our memory on how we graph an equation. If your equation is in slope-intercept form, so the equation shown here is in slope-intercept form because y is isolated and it's equal to a coefficient m times x plus your y-intercept, which is b. So in this case, the m, or the coefficient on x, is 3. That is my slope. So here the slope m is equal to 3, and my y-intercept is b. That y-intercept is a -2. So to graph my equation, I go to the y-intercept, which is the point 0, -2. The y-intercept is where the graph crosses the y-axis, so that would be the point right here on my graph, where x is 0 and y is 2. And then my slope is 3, or 3 over 1. 3 is the rise, which means I'm going up 3 because it's positive. And 1 is the run, which means I go to the right 1 because it is positive as well. So starting at this point, I can go up 1, 2, 3, and to the right 1. I can go up 1, 2, 3, to the right 1, up 3, right 1, up 3, right 1. And we see that those points do all follow a linear pattern. Now, because I can divide two negatives and still get a positive 3, I can have -3 over -1, which just means I go down 3 and left 1. So if I follow that pattern for each of these points, I see that I can go down 3, left 1, down 3, left 1. So I can find even more points on my graph by going down 3, left 1, down 3, left 1, down 3, left 1. And then I connect these points to the best of my ability to draw my line. This graph represents every possible x-y pair that will solve my equation. So for example, if I plug in an x value of 1 to this equation, then I should expect to get out a y value of also 1, because the point at x is 1 has a y value of 1. If I plug in an x value of 2, so now here I am at 2, if I take x and plug in a 2 to my equation, the point on the line at 2 has a y value of 4, which means when I plug in a 2 for x, I should get a 4 out for y. So this line represents every possible solution to my equation y equals 3x minus 2. I'd like to go ahead and test this out and just show you exactly what I mean. So let's say I have an x value of 3. Well, according to my graph, the point on my graph that has an x value of 3 has a y value of 1, 2, 3, 4, 5, 6, 7. So I'm going to go ahead and test this out. We are saying that when I put in an x value of 3, I should get out a y value that is 7. So I've got a y value equal to 3 times my x value, which is 3, minus 2. Y equals 9 minus 2. Y is 7. So that does in fact work out. When I put in an x value of 3, I got out a y value of 7. I'm going to go ahead and do this one more time just to make sure we're comfortable with the concept. I'll go ahead and do a negative x value this time. Let's say I've got an x value of a -1. Here, if I have an x value of -1, the point on that line with an x value of -1 has a y value of -1, 2, 3, 4, and 5. So my point on this line is -1, -5, which means when I plug in an x value of -1, I should expect to get out a y value of -5. So we'll go ahead and try it out. Y equals 3 times, now I'm putting in an x value of -1, minus 2. y is equal to, 3 times negative 1 is a negative 3, minus 2. I've got 3 negatives and 2 more negatives for a total of negative 5. So sure enough, I got out a y value of negative 5. Now this will work for any point on your line. No matter which point you choose, it will be a solution to your equation. So I can even pick this point right here. Now I don't know exactly what the x value is because it's not on one of my increments. Same thing for y. I don't know exactly what that y value is, but whatever they are, it's about 1.5 or so for x and about 2.5 or so for y. Whatever those x and y values are, when I plug in my x, I will get out the y value that is the coordinate for this point. So go ahead and take a moment to pause the video and practice graphing this equation on your own. My slope, m, is a negative 5, or since we want a fraction, negative 5 over 1. My y-intercept, where the graph crosses the y-axis, is at 7, or the point where x is 0 and y is 7. So I go to the point 0, 7, 1, 2, 3, 4, 5, 6, 7, that would be here. And my slope is negative 5 over 1, which means I go down 5, right 1. So down 1, 2, 3, 4, 5, right 1. I can follow this pattern again, down 1, 2, 3, 4, 5, right 1. Down 1, 2, 3, 4, 5, right 1. We can also move that negative down to the denominator as long as there's only one of them. Doesn't matter if it's on the top, in the middle, or on the bottom. So this tells me that I can go up 5 and left 1. 1, 2, 3, 4, 5, left 1. Either way, those points are all in a line, so I will draw the line to the best of my ability that connects those points. Now this line represents every possible solution or xy pair to the equation y equals negative 5x plus 7. Every single point on this line works when we plug it in for x and y in my equation. All right, I've got one more for you to practice. In this example, we've got now 2 equations that I would like for you to graph on the same coordinate plane. So you've got 2 lines, so somewhere on your coordinate plane you will have 2 different lines that you are graphing. It might be helpful to do them in different colors. That's what I'm going to do when I complete them. Go ahead and pause the video and try these 2 on your own. All right, so for my first line, I have an m value or a slope of negative 2. So I wrote that as a fraction, negative 2 over 1. Since we do have a negative, I can move that negative to the top or to the bottom, or in the middle. As long as there's only one negative, it doesn't matter where it is in a fraction. So starting at my y-intercept, which is in this case a positive 9, I go up to positive 9 on my y-axis. And then from there, I use my slope to find the remaining points. In my first slope, the first way that I have it written, this means I go down to right 1. So down to right 1, down to right 1, down to right 1. Notice how I followed this pattern until the end of my graph. I want my line to be as accurate as possible, so I drew all the possible points that I could until I ran out of graph. When we are solving by graphing, it is extremely important for your graph to be as accurate as possible. Then, to make sure that I get all possible points, I also went up to left 1 using the second version of my slope, and I have no more points that I can graph on my line. For my second equation, the coefficient on x is a 7, which means that my slope is 7. To write it as a fraction, I've got 7 over 1. Or I can also divide 2 negative numbers and still get a positive 7. So both of these are equivalent to positive 7. And my y-intercept, since there is no number outside here, I can assume that my b is 0. So I start at the point 0, 0 for my y-intercept. And then my slope says I need to go up 7 because it's positive 7 and right 1 for a positive 1. So up 7, right 1, and I put a point on my graph. Now to make sure that I have all possible points for my line, I also went from my origin down 7 and left 1 to find that next point on my graph. Now I can't do any more points after that because I do run out of graph. If I go either down 7 or up 7, I am beyond the bounds of my graph. So I've got 3 points and I draw my line as accurately as possible. So that red line represents all possible solutions to the equation y equals 7x. So my blue line represents all possible solutions to my first equation, which is negative 2x plus 9. My red line represents all possible solutions to my second equation, which is y equals 7x. So that means something very special about the point where the two lines cross. That point where the two lines cross, then, is the point where both equations are true. So this must be a solution to both equations. It's on the blue line, so it has to be a solution to the blue. It's on the red line, so it has to be a solution to the red. So therefore, it's a solution to both. So the conclusion that we make is that the point of intersection or crossing and this point is, it looks like 1 for x and 1, 2, 3, 4, 5, 6, 7 for y, so 1 comma 7, is a solution to both equations. So that means if I take a x value of 1 and I plug it into both equations will give me a y value of 7. I'm going to go ahead and test this out. So in my first equation, I've got y is equal to negative 2, and I want to see what happens when I plug in a 1 plus 9. So y is equal to negative 2 plus 9, which means that y is 7. So sure enough, when I put in a positive 1, I got out a 7 for y. In my second equation, y is equal to 7 times x, which is 1. 7 times 1 is 7, and sure enough, when I put in a 1, I get out a 7 for y. So that ordered pair is in fact a solution to both equations. Go ahead and take a moment to pause the video and try this next slide on your own. We are going to graph both lines and identify the point of intersection, which will be the solution to the system or the solution to both equations in our system. So my first line with a slope of 1/3 and a y-intercept of negative 5 would look like this blue line here. I went down to negative 5 and put my y-intercept, up 1, right 3, up 1, right 3 until I ran out of graph. And then I can also go down 1, left 3, down 1, left 3 until I ran out of graph. The second equation I completed in red. I've got a slope of negative 1/2, so negative 1 over 2, or I can move that negative to the bottom and have 1 over negative 2. My y-intercept is 0, so I start my graph at the origin where y is 0, and then following that first slope, I've got negative 1, positive 2, down 1, right 2, down 1, right 2, until I run out of graph, and then I follow it to the left, going up 1, left 2, up 1, left 2, and so on until I run out of graph. So the conclusion that we can make is that the point of intersection is a solution to both equations. So that would be the point 1, 2, 3, 4, 5, 6 for x, and negative 1, 2, 3 for y. So 6, negative 3 is a solution to both equations. So when I plug in a 6 for x in my first equation, I should get negative 3 for y. And sure enough, doing that, I see that I do. For the second equation, I should get a negative 3 when I plug in a 6 for x as well. And sure enough, I do. Therefore, that point 6, negative 3 is a solution to both equations. There are 2 more here for you to practice. Just graph each line and see where the point of intersection lies. Thanks for watching.